Chapter 6.4 Basic Exponential Shift. Quick recall from Chapter 6.1 Day 1. So we are going to graph the following as remainder part of this section, where we're going to graph y equals 2 to the power x. Step number 1, identify the value of the base. Is it greater than 1 or less than 1? In this case, you can see that the value of the base is greater than 1. So, which means that this is going to be a growth. And then we are going to make a table. To table values, we are going to write -2, -1, 0, 1, 2, and 3. And we are going to plug it into the equation 2 to the power -2, and that's going to be 1 over 2 to the power 2, and that's 1 over 4, or 0.25. You're going to next put 2 to the power -1, 1 over 2, and that's 0.5. 2 to the power 0 is always 1, and 2 to the power 1, just 1. 2 to the power 2 is 4, and 2 to the power 3 is 8. Next thing is we're going to plot these points on the table, draw the graph from left to right, a smooth graph, as much as smooth as possible. So let's see what we have here is -2, 0.25, -1, 0.5, 0, 1, 1, 2, and 2, 4. Next we have 3, 8. So that's going to be this point. Try to make as smooth graph as possible. So you're going to have a growth graph rising from left to right, where you're going to have 0, 1 as your y-intercept. For graphing y equals 1 over 2 to the power x, you're going to identify the base. The base is 1 over 2, which is less than 1. So that's going to be less than 1, which means this is going to be a decay graph. And you're going to use the value for x -3, -2, -1, 0, 1, and 2. And you're going to plug that in to the function 1 over 2 to the power -3, which means 2 to the power 3, and that's going to be 8. 1 over 2 to the power -2, so that's going to be 2 to the power 2. To make the negative into positive, you flip the inside, so that's going to be 2 over 1. So 2 to the power 2 is 4. 1 over 2 to the power -1 is just 2. 2 to the power 0, 1. 1 over 2 to the power 1 means 1 over 2, that is 0.5. 1 over 2 to the power 2, which means this is 1 over 4, and that's going to be quarter, or 0.25. You're going to plot all these points. So if you start from the left end, you have -3 and 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be -3, 8, -2, 4, -1, 2, 0, 1, 1, 0.5 center, and 2, 0.25. Try to make smooth graph, and this is going to be a falling graph from left to right, and that's going to be your decay graph, where 0, 1 is y-intercept, and 1, And 1 comma b, 1 comma b means 1 comma 1 over 2 is your this point right here. In this case, we are going to graph the following function on Desmos and describe how the parent functions have transformed. The parent function for these two is y equals 2 to the power x. So if you want to graph this, this is going to be your rising graph or growth graph, and your points are going to be, so this is my 0 comma 1. Next is this point and this point, 1 comma 2 and 2 comma 4. So this is my graph for 2 to the power x. So here is the graph we made for the 2 to the power x. Now we are going to describe the transformation. This number plus 3 is right next to x. It means this is a horizontal transformation. So if it is plus 3, then you're going to move left 3 units. So each point, which was these points, are going to move 3 units to the left. So this point is 1, 2, 3. This point is move 1, 2, 3. And this point is move 1, 2, 3 here. So that's going to be all the points moved 3 units to the left side. So this is going to be 1, 2, 3. That's going to be this point. 1, 2, 3. So this point. And then you're going to make a smooth graph. And that's your graph for 2 to the power x plus 3. So asymptote is the same for both. Asymptote is same for the both graphs. So in this case, I graphed the y equals 2 to the power x here. And now we are going to graph this function. Plus 3 outside the function means move 3 units up. So which means that the original graph, which we had it here, this one, is a 2 to the power x graph. We are going to get the new graph, that is this one, which is moved 3 unit up. So all the points that you see here, so this point is moved 3 unit up. So that's 1, 2. So this one is moved 1, 2, 3. So this is my new point. So that's going to be 1, 2, 3. And this point as well, for the one in the center, move 3 unit up. So 1, 2, 3. So my new point is going to be here. And this point, which is y-intercept was 0 comma 1, is moved 3 unit up. 1, 2, 3. So this is my new point. And next is this point, 1, 2, 3. So that's going to be moving up here. And then here you're going to get the graph that is this graph, which is moved 3 units up from the original graph. In this case, if you see that my line where the graph is actually approaching is this line. And this line that I'm drawing, new one, that's a red line, is an asymptote line. So asymptote line is moved 3 unit up. So asymptote new line is y equals 3. So this was my line, that is x-axis line, or y equals 0 line. It is moved 1, 2, 3 unit up. So now my asymptote line is this line, and this line is y equals 3. So anytime the graph is moved left or right, your asymptote does not change. The asymptote becomes same. So asymptote is same for all the movement that is left and right, but asymptote do change when you move the graph up or down. So if it is moved up, it means this line is moved up 3 unit. If this line is this is moved 3 unit down, then you're going to move this line 3 unit down. So next we are going to graph y equals 1 over 2. 1 over 2 to the power x means that you're going to have b as 1 over 2 that is less than 1. So which means that these are decay graphs. So decay graphs, once you want to graph this one, and then you're going to apply the transformation on these graphs. So first thing you want to do is to graph this function. This function we graphed it in example 2, so we're going to follow the same points. It was the point that is 1 comma half, and that is 2 comma 0.5. 0 comma 1 was your y-intercept, and then negative, so negative 1 comma 2, negative 2 comma 4. Join all these points and you're going to get the graph that is the parent graph y equals 1 over 2 to the power x. Now we are going to graph this function, and this function you can tell from x minus 2. If it is minus 2, that means that you're going to move this graph right 2 units, which means that each of the points are going to move right 2 units. So let's start with this one. If this is the point right here, moved 2 units to the right, so that's going to be this point, which is 1 comma 1 over 2, move 2 units to the right, so 1 2. So this is the point. This point 0 comma 1, move 2 unit to the right, 2 unit to the right, and you're going to get the graph that is this graph. Again, this graph is moved right 2 unit. It means asymptote is same. So the asymptote line, which is this line right here, is same, because if you move this line 2 unit to the right, is still going to be the same line. If you move this line 2 units or few units to the left, is still going to be the same line. So this line is same, the transformation right 2 units, and this is our new graph. So I'm copying the graph of the parent function, this parent function, the same that I graphed here in the black pencil. So this one is our parent function for y equals 1 over 2 to the power x. Now we are going to figure out what is this graph is going to be. The negative 5 is outside of the function. It means this is going to be used as moving the graph left or right, sorry, up and down. So this is going to be move 5 units down. So the graph all the points are moving 5 units down. This asymptote line is moved 5 units down. So this line is moved 1, 2, 3, 4, 5 here. So this is my line, 5 units down. And all the points, this is moved 5 units down. So this is going to be my 2.5, 0.25, half. This point is moved here, and this point is moved right here. And the next one, or the last point, that is this point, is moved 5 units to down. So 1, 2, 3, 4, 5 down here, and then join all of these points. You're going to get a new graph, and the translated graph, that is 5 units down, and asymptote is moved, asymptote line is moved 5 units down. And all the points are moved 5 units down, and you got the new graph. That is a translated graph that is moved 5 units down. So the core concept on transformation of exponential function, you're going to use fx equals 4 to the power x as your parent function. What is the horizontal translation? Horizontal translation means you're going to shift the graph. So shift left or right. That what means moving or translating horizontally. So if it is left, you're going to have x plus h, and if it is right, you're going to have x minus h. Example, 3 units right. 3 units right means you're going to have 4 unit 4 x minus 3. In this one, you're going to have 4 x plus 2. For vertical translation, you're going to shift the graph up or down, which means that is going to be outside the function. So plus means you're going to add k, subtract, or down means you're going to subtract k. 5 units up, the example for this one is 4 to the power x plus 5. 1 unit down means 4 to the power x minus 1.